Let me do a quick run through the data model, just so you know how it basically works, what's involved. HBase, we float big tables. You're like an Excel, like a bunch of Excel spreadsheets. We run them on your on a cluster. A table is made up of columns, column families by rows. A column belongs to a column family. A column is named by, you must identify its column family, its prefix first, and then there's usually a qualifier that follows. As your table grows, HBase will automatically split it up into regions. These regions are the things that then we distribute around the cluster. This is how we scale reads and writes. It's done for you automatically. Everything in HBase is about byte arrays. We don't have any native types. We're often called, we have sort of a schema, but we're often called just schemaless. So we usually are cast in that NoSQL category. Will usually be mentioned there. Everything in HBase is sorted by row, and then like along a row, the columns themselves are sorted. And then everything is versioned by, there's this, like, you have this third dimension, usually by timestamp. But you can set the version yourself. HBase is strongly consistent. We favor consistency over availability. We're also atomic on a row, so that if a row is 1 million columns wide, and you update like 10,000 rows, you'll either see all the updates or you won't see any of them. It's a picture. It's a bit messy, but HBase clusters are made up of masters and slaves. There'll be HDFS in the mix as well. You usually co-locate a HBase region server beside a HDFS data node. We have the same kind of setup where we have master nodes that direct the cluster, do things like bootstrapping and stuff like that. So you have the HDFS name node and then the HBase master node. Just a rough picture of what it looks like. We're part of the Hadoop family generally, so we're pretty well connected to the rest of it. So there's good MapReduce connectivity. We have an extensive set of filters, so you can do like filtering on the server side, so you don't have to return data to the client, just only to drop it because you're not interested. We have a kind of a database triggers sort of notion where you can alter the behavior of the server itself. Co-processors is what we call them. We have a shell. We do, like any database, we can replicate from one HBase cluster to another. It might be in data center or across data centers. And we fit into the general Hadoop security model so that you can have a security that spans your Hadoop data, HDFS data, but also the same security applies when you move into HBase. And if you're map reducing or whatever, it's all the same security model. What to expect: writes 1 to 3 milliseconds per record, 1 to 20K writes a second per node. Reads, if it's coming out of cache, it's pretty good. Throw in an SSD and everything is better. Cell sizes, usually a couple of bytes up to 3 megabytes. If you go beyond that, then you should probably put your data somewhere else, maybe into HDFS. We're basically column orientated, so wide tables are okay. Sparsely populated rows, that's fine. You don't have to fill in everything on the row like you might do in you're not paying anything extra as you are in an RDBMS, traditional RDBMS. Who uses it? Here's a few labels. These are probably the bigger users. Let's talk about a few production use cases. Probably the most well-known one is HBase use at Facebook. They talk about it quite a lot. They use it in quite a few applications. They do both like OLTP serving out of HBase and batch. Probably the biggest HBase application is Facebook Messages. Every time you type something into Facebook or you post something on somebody's Facebook wall, it's going to end up in a HBase cluster. Facebook Messages, is 1 billion plus users, tens of petabytes for compressed data, thousands of machines, but they shard the namespace by, they shard it into pieces, and then each shard is carried by a cluster of 100 to 200 nodes. This is good for if you have to do updates, upgrades, or if maybe you're having a problem with one particular cluster, the whole namespace is not taken offline. And then at the other extreme, their whole metric system is done up in HBase. It's the eyes and ears for Facebook. It's like, and they cannot afford for it to go down. It has to be up all the time. It's so critical they actually write to 2 different clusters. So if one is having trouble, they can switch to the other. Other HBase use cases, Pinterest in San Francisco, they're just down the road from us. They run everything in AWS. And they have it depends on the use case, but they have different clusters. Some run on SSD, some are on SATA drives. They're serving billions of page views a month out of HBase clusters. Flurry, they're just down the road, but in the other direction. This is probably, these fellas have been around HBase for a long time. They're really early versions. This is the biggest known contiguous HBase cluster that we know of. There's, in 2 data centers, they have 1,000 nodes each, and they're doing master-master replication between the two big clusters. And then separately, they have a small cluster of about 12 nodes for doing like low latency serving, and then at peak time, they're doing like 1 million reads a second out of this low latency cluster. Another one that's been talked about quite a lot is the use by eBay of HBase at the core of their indexing infrastructure. When you buy something on eBay, the data sources are myriad, and they come from many different places. There's like 30-odd databases out front, and they pull all the data into HBase to get a consistent view on their total data set, and from there they build their HBase index. So a lot of churn every day as new items come in. 2 big clusters in 2 different data centers. This stuff is growing. So it's used in quite a few different kinds of ways. It's like OLTP and maybe a bit of OLAP going on. There's the kind of the storage dumping ground where, say, a website will just serve all of its features out of HBase. Engineers like it. They don't have to worry about scaling. It's done for them. Somebody else is worrying about it. There's a reconciliation store that I just talked about that eBay uses it for. Time series is pretty popular. Salesforce are building, their metric system is built on HBase. The Facebook ODS that I talked of is a time series type database. And then just your lots of entities store. You couldn't put it in an RDBMS. There's too much stuff, whether people doing human genome kind of projects or Facebook Messages, for example. So HBase is an open source project. Who runs it? These people, each of these companies has like a couple of committers at least, 2 or 3 committers. They have teams working on HBase, and they all come together to push the project forward. It's a pretty diverse team. We're proud of our diversity. We work hard at keeping up our diversity. So that's why I have this little poster down here. If you're interested at all in open source or contributing to something like HBase, we'd love to have you. Come talk to me afterwards if you can't figure it out. But yeah, we work at our diversity, so we're encouraging, we're welcoming of people. We like to have new people show up on come help out. There's a few slides on our development rate. It's just a Git report. Generally the lines of code are growing. The lines of comments are not so big. Maybe we should comment code better. This is open issues versus closed issues. As you can see, the people are opening issues faster than we're closing them. The green should be overtaking the red. This graph is a bit interesting. It's commits over time by contributor or committer. And what you see is that who's committing when is changing, and I suppose it makes sense. It's human. People come and go. They're interested in the project for a while, or their feature gets committed and they move on to something else. So it's important to keep for a healthy open source community. It's important to keep keep people, keep bringing in new people, because people kind of, they age out as time goes. So that goes back to my point earlier of encouraging new blood. HBase today, I suppose we've been running on release 0.94 for quite a while. It's been released about every month. Each one gets more performant, more stable. We're on to release 13, so that's almost more than a year of 0.94. And the reason we've been so long on one version is because this one took a long one to come out. It was just released in October. It was about 18 months in the making, more than 2,000 fixes in it. The big themes: improved stability, operability, insight onto what's going on in the cluster for operators. And also scaling. We've run into some interesting issues, stuff that made sense at 100 nodes or 200 nodes actually starts to become a problem when you go bigger. We've had to fix a bunch of that stuff. And then, as developers, we've tried to put ourselves into a position where it's easy for us to move forward while keeping the cluster up serving, and not having to bring it down. I'll just run through this stuff pretty quickly. Just sampling of the issues that were fixed. Our compression stuff was our compaction stuff was redone. That should be pluggable compaction, not pluggable compression. When it gets triggered, it's been improved. We run on Hadoop 1, Hadoop 2, smarter balancing of our regions. Region assignments hardened. You can influence the behavior of the server in more ways. There's more hooks been exposed. I talked earlier about HBase being a consistent store. And what that means is we won't show you old data. We'll only show you what you wrote. We'll never show you the old stuff. So what happens when a node crashes? It's going to have some edits in memory, and if it crashes, those edits will not have been committed. What happens then? We have to do a repair. So the window during which a crash is noticed, the repair is affected, everyone is notified that the repair has happened, it used to be pretty wide. So spending a bunch of time on narrowing that window is a lot of what was done in HBase 96. We get your data back online quicker. We moved everything to protobufs. Previously, we used Hadoop's hand serialization. Every object you had to define how you wanted it serialized, and then you had to write how you wanted to read it back off the line again. This is fine when Hadoop was small, or when your class or your application was small, but when things got big, it became unmanageable, and it made it difficult for us to move forward. So we moved everything to protobufs. You write an IDL describing the objects, and then it generates the objects for you, and these are what you actually go against. So everything in HBase, our system tables, where we touch the file system, when we write into Zookeeper, or even our RPC, when we write across the wire, everything's been protobuffed, moved off of Hadoop's writable serialization format. Yahoo contributed namespaces. This is like MySQL's database notion. Your grouping of tables, and the idea is More and more, HBase clusters are being deployed in multi-tenancy kind of contexts. And so we need to be able to guarantee, SLAs and, isolate users from each other. And so this is like an important building block moving forward so that we can do better multi-tenancy serving. And there's much more. There's query tracing, new UIs, online merging, hardened replication. The metrics been redone. There's loads of metrics now, and they make sense. They follow patterns, so it's easy to figure out what stuff means. 98 will be next. By the end of the year, rolling upgrade from 96 onto 98. You'll be able to tag the cells themselves, the actual things that contain data. You'll be able to put arbitrary tags on them. So now we'll be able to do even more fine-grained security. Bringing ACLs. At the moment, we have ACLs for table and column family, but now you'll be actually able to do it on the actual cells themselves. Define who can see stuff. And things like reverse scan, stuff that people have been looking for a while. In 2014, we'll probably have a HBase 1.0. I think the general sense is that HBase 98 is going to be 1.0. And we'll be working on things like reining in the 99th percentile. Sometimes if you hit a bad disk, or if you're running on something like Amazon's web services where the substrate is not guaranteed, it can be a bit wobbly. HBase should be able to just write over it all and give you consistent read and write responses, regardless. I think, I've talked about more support for multi-tenancy. We're seeing HBase being deployed in more multi-tenancy kind of setups, and people are working on this. And I think, we're a Java application, so we'll be spending more time getting stuff off heap. Quick few notes on HBase ecosystem. TSDB, sort of like OpenTSDB is this sort of a killer app that runs on HBase. It's killer application. It's great for recording all the metrics that you have in your data center from switches, machines, application. You dump them all into TSDB. And then you can graph them afterwards. You can put different attributes up against each other and have them all shown in the one graph. So it makes it easier correlating events like, oh, there was a slow disk at this time. My SQL query was slow at the same time. Must be bad disk. It's good for doing this kind of diagnosis. TSDB is useful because most metric systems, they'll do RRD. They'll roll up the metrics. Like they'll roll the metrics for an hour up into a day, and then you lose the granularity. TSDB just keeps everything. So if you had the outage 2 weeks ago, but you only got time to look at it today, the data's still there. You're not losing it. This project is doing very well. A local team here have written Heinze, which is a transaction engine on top of HBase, inspired by Google's Percolator. So you can do transactions cross-row and cross-table. And then a bunch of projects are working on what I call the gap. What's the gap? The gap, so over here on the left is my electricity bill. I get it every month. This is me in the blue. I use more electricity than my neighbors, apparently. I can't figure it out. So here's a nice application. This thing is written on HBase by the people at O-Power in San Francisco. And then on here you have this raw API that's byte array based. How do you span this gap? How do you make it easier to write applications against the raw byte arrays of HBase? And it's not just byte arrays, because if you don't lay out your data properly in HBase, you can the performance can be really bad. So how do you prevent users from you know, making mistakes. A few people are working on frameworks where they boil in the decisions for you. They'll stop you from shooting yourself in the foot. One in particular has been around for quite a while now is the one from our friends at WeBeData, Kiji.org. They have they'll allow you to do some simple entity modeling on top of HBase. They add types, compound types. Every cell is versioned, so things like migrating your schema from one version to the other, they've taken care of it for you. They manage it for you. There's a few machine learning libraries thrown into the bucket, so you have a nice tool set to work with. And you have to worry less about running your HBase cluster. Similarly, Cloudera development kit has support for HBase, and it does similarly. It gives you an API, and you don't have to worry about the details so much. They worry about it for you. And then there's SQL. People have been going to the data store via SQL for decades now. Why can't you do that? If you could get to HBase from SQL, wouldn't it be more friendly, more familiar? So Salesforce have been working on Project Phoenix. It's a SQL layer on top of HBase. It's very nice, just looks like a JDBC driver. HBase looking like any other database. And it's fast because it's got its fingers into the guts of HBase. And the people there know how HBase works, and they've exploited all the filters and the triggers, and they can make it run fast. Before I finish, just a few words on beyond HBase, on the Hadoop ecosystem. We'll graduate from the HBase ecosystem up to the Hadoop ecosystem. So the Hadoop family itself is evolving. It was always about batch. But what we're seeing now is that it's more is evolving towards more real-time and streaming kind of applications. And I think it's fair to call the release of Hadoop 2.0, which happened, I suppose, last month, a sort of an inflection point. This stuff has been building for quite a while. And it's not just the release itself, but I think it's, when we look back, we'll say Hadoop 2 would be the time when people started talking more about Hadoop in the real-time, near to real-time, and the streaming space. I think the inflection point was underlined by the conference that was had last week or 2 weeks ago, Strata Hadoop World. A bunch of new distributions came out. It was sort of like a coming out party for Hadoop 2.0. Lots to talk about enterprise. So Hadoop itself is no longer just about batch. That's the point I'm trying to make. There's people have, Yarn's been coming for a while. I think Arun was saying it was something like 5 years in development. But Yarn adds, on top of your cluster, it does distributed scheduling and kind of a resource management. And you can write, it's a framework where you can write distributed applications on top of what was your MapReduce cluster. You only was able to do MapReduce. Now you can do more exotic things, more interesting things. There's like the TES initiative where you can do directed acyclic, it's taking care of doing directed acyclic graph processing for you. And then on top of this, they're building the Stinger effort, which is an attempt at speeding up Hive. All this is being built on top of Yarn. Then you have the Storm framework, which kind of is like a streaming version of Hadoop. This has been around for a while too, but it's just been added to Apache recently. Yahoo then went and they took Storm and they built it on top of Yarn. So Yarn takes care of the distribution of Storm for you. from Berkeley in California. There's the Spark project, which just recently became Apache Spark. This allows you to load data up into memory and run queries against it on your cluster. Another important project from Berkeley is the Mesos one. Machines are getting bigger and bigger. You can't have an application, you can't have a machine per application. You need to be able to, I suppose, cut the machine up into pieces and hand it out to your distributed app, piece at a time. And Mesos allows you to take care of this resource management problem. And then there's, Corey was talking about Dremel, and then outside of the Google firewall, there are other projects that do similar. There's Cloudera's Impala. It allows you to do scalable, low latency SQL queries against what's in HDFS or against HBase itself. Apache Drill is another project that is similar. So I think just the general point, it's no longer just about batch. The Hadoop ecosystem is moving more towards real-time, near to real-time, and streaming kind of workloads. And don't forget HBase. HBase is in the mix too. We do close to real-time as well. I'll leave it at that. Thank you very much for having me.